So Debbie already introduced me. I'm the director of the John Olson Advanced Manufacturing Center. It's a new advanced manufacturing center we're setting up at the University of New Hampshire. Our grand opening is scheduled for June 1st. Everyone's welcome to come and see what we're going to be doing. So I'm going to let each of the panelists introduce themselves, and they may have a few opening comments about mixed reality. So we'll just go right down the row here. Go ahead.
All right. Hello? Oh. I'm Bryce Notice. I'm from Raytheon Missile Systems in Tucson, Arizona. But the reason I'm up here is because for about 8 years now, I've been working in what we call the Immersive Design Center. We focus on, or our focus in the past has been large-scale virtual reality, getting 20 to 30 people in a large-scale virtual reality system, flying through our designs, but with a manufacturing focus. So being able to bring in all of the different important stakeholders along the product life cycle into that design phase to create more manufacturable, more producible products. More recently, in the past couple years, we have ventured into more of the individual and more interactive experiences, still virtual reality, where we're getting into assembler training and maintenance training, and kind of marrying the two, large-scale virtual reality and individual virtual reality. So very much a virtual reality focus from me up here.
Hi, I'm Greg Harrison from Lockheed Martin, Rotary and Mission Systems in Orlando. We've been working corporate effort to bring augmented reality, which is also mixed reality, into our manufacturing and logistics work. So I've been, for the past 8 years, developing optical lenses for augmented reality, optical see-through HMDs, head wearable devices. And we've also been working with the mixed reality overlays of certain testers and F-35 aircraft parts in order to provide for training, maintenance, and manufacturing of the items, doing away with the previous paper versions and getting the overlays so that we can hopefully improve our ROI.
Good morning. I'm Kurt Hoffmeister with Mechdyne. I'm responsible chief technologist with the company. Those of you not familiar with Mechdyne, it's been around for more than 20 years, and during that time, I've primarily worked in the area of virtual reality and mixed reality. Much like Bryce, the last few years has seen more and more augmented reality as part of that. Mechdyne is probably best known for large immersive displays. There's 2 examples of that here at the show. I'd encourage you to visit Genesis System at the front of the hall. And Mechdyne is also doing a VR demonstration in the SME booth number 436. During that time, many of our clients have been research organizations looking at manufacturing, design, training, a whole variety of issues using virtual reality technology. But I'm happy to say today many of those clients are applying what's been researched over the last many years to their daily operations. And that's something I'm definitely excited to talk about. Lockheed Martin has in Denver the Computer Human Interface Lab, and that's a real good example of a large screen display as well as head-mounted displays being used together so that many participants can share the same virtual environment, observe or participate in a training or a procedure that's being simulated. So I'm excited to talk about all those things.
My name is Roger Richardson from Delta Sigma Company. Back in 2005 at Delta Sigma, we started thinking about augmented reality. Our first installation was in January of 2008 on the F-22 vertical stabilizer. And since that time, our augmented reality system called ProjectionWorks is presently installed on 22 different aircraft production line or aircraft in 31 different production lines, different locations around the world. We are also over in the SME Solution Center for Augmented Reality, and if people are interested today in learning more about augmented reality. One of the things that we have over there is an F-35 setup that is, it's a simulation of work that actually happens using augmented reality on that part of the F-35. That particular part, the Air Force published that for an investment of about $3 million, they're receiving an $82 million return on that investment in their total recurring flyaway cost. And we also have a booth back here behind you. If anyone would like to learn more about it, we'd be very happy to talk to you about that.
I'm Scott Bryan with the Air Force Research Laboratories Manufacturing Technology Division. We've been involved in developing and funding projects to get augmented reality into our OEM manufacturing lines, and we've seen drastic improvements in throughput and quality. We have a few ongoing projects to take this technology to the next level. And also, we're looking at transferring it to the logistics environment for aircraft maintenance. And we consider that more of an enterprise rollout, and it has infinite more challenges in making that transition.
Very good. So first question, what are some obvious examples in manufacturing specifically where you guys have had experience in implementing augmented reality, mixed reality, virtual reality, choose your flavor. Give the audience some really hard case examples of where you find these particular operations very conducive to using this new technology. Anyone can go, it doesn't have to be in order. Yeah, sure.
I'll take it first. For augmented reality in production. So for example, things that are long and tedious and complicated, where we're seeing a sequence of work instructions come to you one thing at a time. It's on a drawing, you could potentially on a drawing, there might be 100 steps that have to be done, and you have to keep in your head which ones are done, and the technician is probably choosing the order that he would do it. With augmented reality, we would spool those steps out in 100 steps. If there's a 100 steps, you would only see one thing to do at a time, and in any particular moment, you're only doing one thing. So there's all of the rest is noise at that point in time. So things that are long and complicated. So if you've got a production line where you're rolling out an airplane, say every 10 days, then everybody's work is 10 days long, and it's sufficiently complicated that it's not safe to just say that you could memorize that, particularly when you've got configuration changes coming along and there's maybe multiple variants. So it's where errors happen. So things that are short and simple, probably not a good application for augmented reality.
Anyone else? Yeah.
And I would say that typically a lot of the clients we work with are on the support side of manufacturing. So a little bit earlier in the life cycle, they're using virtual reality to simulate and plan the 100 steps for assembly. And then that makes a really nice feed into augmenting it on the production floor. So VR isn't required, but it can be a nice precursor to the actual application.
We found that for AR, for cabling on items on the manufacturing floor, it enabled us to get away from the paper, and it also provided a method to give you much more information than you could get from a piece of paper. And we found that in a lot of cases, paper instructions sort of left out things. But when you had to go to a augmented reality experience, you had to provide enough to match reality, because you've got the actual physical piece of hardware there, and you have to overlay it. Then you also have to be able to see it from different sides. So if you're wearing something like the HoloLens and you go look at the device, you don't just look at it from the one viewpoint like a picture might provide. You are able to move right in and look around it, look behind it, look at the various connections, look at all the parts. So it requires much more detail, but I think it gives you more accuracy and a better chance of getting it right the first time.
Have any of you experienced using any of this technology for maintenance-related activities?
Yes, we've used it for maintenance. We developed pilots for maintenance, like on F-35, and in that case, you would translate the maintenance procedure, and it's not a one-for-one translation, although you have to get all the information in there, and you're referring people to pictures in other books, or do this procedure, and you have to make that available in AR so that you can get that where you are hands-free without having to refer to books that you don't have. So for maintenance, obviously, you got your hands available to do two-handed maintenance while you're looking at something perhaps in a distant area that is provided for with the imagery that you see. Also, the maintenance procedure, again, is tends to leave stuff out, perhaps. So when you go to make the real procedure, you'll realize that there are steps left out and you have to add in more, but it helps to really get rid of ambiguities that would otherwise pop up.
The devices themselves have become so affordable that we've seen some of our units actually purchase like a HoloLens device and start authoring instructions to do aircraft maintenance. From an enterprise approach, that makes us nervous because we have zero control over what the airmen are doing, but we do realize the utility, and we're trying to make sure that we can transition that across the Air Force in a smart manner.
Yeah, and along the lines of what Kurt said for the last question, it's really important to bring in those people that are more maintenance minded, more manufacturing minded into the design phase, and that's what I think what you were kind of saying is you have to be more detailed, but you're able to walk around whatever part it is, and the more stakeholders that you can get to have that understanding of the design early on, the more maintainable you can create products using these types of tools.
So I've read where you can take something like Google Glass. I know there's a lot of competing products to Google Glass, so I'm not here to necessarily give a pitch on Google Glass, but take that as an example. And you have a junior technician that might be troubleshooting a problem, can call back to the home office where the senior guy is and be able to translate directly because the senior person can see firsthand what the junior technician is looking at. Have you had any experience with that kind of use of this technology?
I would say yes. Typically, people are more likely to use an iPad, which isn't as hands-free, but has all that capability of displaying information and doing a camera session with a more experienced technician or support person. So many times that specific case would be prototyped using something more like a tablet or a smartphone, but with the intent would be to move to a hands-free glasses solution.
Okay.
We've been using Remote AR, which is a scope AR product that is, it lets you do exactly what you're saying. You have a technician out in the field and he has a problem, and then they can dial into a remote expert, say back at in the States, and they can provide overlays of augmented reality onto the products that they're talking about. And we've tested it internationally. It works very well. There's probably like a Skype for augmented reality. Certainly does what you say.
In the Augmented Reality Solution Center that's over here for people who are interested in that, there's a company called RealWear who does exactly this. And you can experiment with it and get a demo of that exact
Awesome.
Process.
So I've also seen examples where for assembly operations you have the next step projected down onto the workbench. It points a green arrow to the bin that you need to pick the next part for. It puts a red X on your hand in the event you go to the wrong bin. Do you have any experience in using that kind of technologies in your operations for assembly?
Yeah, the system that we have is going to provide, as I say, you always see, you can choose to also include the parts bin and parts count of what you're going to pick from those. Also, putting the instructions out onto not just small desktop things, but we put augmented reality on entire commercial airplanes.
Wow.
So there's not a size limitation to this.
Awesome. So let's say you're a small business and you've read about this technology, you've heard some of the exciting things, and you really have no idea how to begin the journey of implementing this technology. What would you suggest for a small business owner, 20-man shop type of operation? What would you suggest they do to figure out how to start a journey towards adopting some of this technology? And could you give us an idea on what you should budget from a cost perspective for your initial implementation, say that first year?
I'll start. The first thing to think about is that you're going to do things differently. You're not just going to take a paper process and convert it to augmented reality. A paper process has a lot of limitations, and augmented reality doesn't have limitations. So the information that you want to provide is easy and simple to provide if you have that information. So the first thing is collecting the CAD model data that you have and being sure that you really understand your process. When we go into new places, understanding the process of how we would like to see this displayed is usually the biggest struggle that we have. So because people are used to thinking inside these limits, and we're saying forget about all those limits, you don't have them anymore. How do you really want to do it? So getting your data together and your process together, that's the first way to start. And then a lot of people run pilot programs, and so for us, for example, we have lease systems, so somebody can try this for, say, 3 months, try to integrate it into their process. There's still going to be some upfront cost in addition to that because you're still going to have the data to do it. But even for in the low tens of thousands of dollars, you could run a pilot program to get started into the process.
I think one of the most important things you can do is to do a detailed definition of your individual use cases, whether that's supply chain kitting or reach back field service support. Just do a detailed use case definition, and then get with the smart integrators. There are just so many products on the market right now and platforms to know what's going to match your application the closest.
Okay.
For a new company to start this, you need to get somebody who does art, digital art, CAD, so they can take, of course you're going to have your stuff in a CAD library, but they have to bring that into something like Unity, which is the major application nowadays. Unity, Vuforia for head wearables. They have to be able to take your CAD and be able to change the polygon count, texture it so that it looks good in your head wearables or whatever you're using for augmented reality. They have to be able to handle the different formats. That's a very important personal effort that has to be done. So either a new hire and they love to do this stuff, and then $50,000 to give them parts, software, and trip to conferences like this to get information.
And yeah, I mean, what I'm hearing from everyone and my experience as well is it is a complete mindset change. You said get away from the paper. Everyone's talking about you want to start at the model. If you do that, then you're kind of building the ability to use this kind of technology into your use cases. So starting with the use cases, starting with the capabilities, and like everyone said, there's a lot of affordable technology out there that you can apply once you've kind of changed that culture and approached all of these design, manufacturing, maintenance issues from more of a virtual, augmented reality, kind of computer-based approach.
Yeah, typically we'll do a discovery discussion with clients because you can spend from a few thousand to several million on your implementation, but the return on investment is what's really key. And if you have a bottleneck that's costing you time, if you have a problem with rework, if you have an assembly process that you just wish was more efficient, identifying those problem areas kind of self-directs the way you approach what's best to prototype or try first. Again, you do have all your digital assets. Almost everybody has no shortage of that. But efficiently using those assets is where you might need an additional staff person to help make that conversion.
Okay. So we've heard several terms already mentioned in your answers. We've heard assisted reality, augmented reality, virtual reality, and mixed reality. Does one of you want to take a shot at describing the difference between those four terms? Sure.
I'll go. I don't know that we'll have unanimous agreement on this because it's, assisted reality is context-sensitive information that's important and useful, but it's not connected to the thing you're working on. So you might be looking at a graphic, it could be a drawing, or it could be textual information, but it's so like the scoreboard, for example, or the scores and the first downs on a football game would be assisted reality. Augmented reality is, well, let me skip over to virtual reality. Virtual reality, you're in a completely computer-generated world. It is not connected to the physical world in any way whatsoever. It's 100% a digital system that you're in. And augmented reality is where you're going to take physical reality and augment it with virtual reality. So some people would also call that mixed reality because concurrently you are seeing a mixture of things that are real and things that are virtual. The augmented reality, again, probably the thing that everybody knows about is the scrimmage line and the first down marker on a football field when you see it on TV. That's not literally on the field. If you're at the game, you don't see that. But as the camera moves, those lines are connected to the field. So they're connected to the coordinate system. The scores is not, so as the camera moves, it stays in your view, assisted reality.
Very good. Anyone disagree? Have a different definition they want to offer?
I mean, I don't disagree. I think it's just important to understand these are kind of common definitions, but if you look out at the internet, different sources, you'll find many different definitions. So make sure to read into, if you're looking into certain technology, make sure you read into what does it actually do, and make sure it matches what you're looking for, not just by the term that's being used.
I would agree with all that. I often use the example mixed reality has been with us for many, many years now in terms of flight simulation or machine operation where you're physically interacting with the real controls, but you're seeing a virtual environment with the response. You know, that's a pretty mature technology that's been around for quite some time.
Very good.
I heard a new one. I heard a new one this week.
Yeah?
It was called Empty Room Augmented Reality. Because normally with the augmented reality and mixed reality, you're like overlaying some part of the real world and augmenting it. In this case, and with virtual reality, you put on these immersive glasses that you don't see anything else, and you can bump into stuff. With the empty room augmented reality, they show just something floating there in the room. So you can see everything else in the room, you avoid the walls, but you see the helicopter floating in the room.
Okay. Can any of you offer your genuine experience as to the return on investment, the payback period, to give the audience an idea of, you know, how long does it take to make a return on that investment you're making?
I can provide some anecdotal information. We have 78 projectors in one location on the F-35 center fuselage, and the Air Force published that for a $2.7 million investment in that particular case, an $82 million anticipated return on investment on that. We have another customer who said that in the first year of operation, they reduced their rework costs were zero from the 1 year mark after they implemented our augmented reality system. The prior year it had been about $10 million. So, and that was probably about a $1 million system. So, and that's only the rework cost. That doesn't count the direct labor savings in that. The studies that we've done, we're seeing an average of direct value-added labor reduction of 72%, standard deviation across skill levels reducing by 71%, and rework cost reducing by 92%.
Excellent.
For instance, in the wiring harness manufacturing, I've heard evidence that there's at least a 10 to 12% quality first-time defect ratio, and with the Harness Works system that we paid to have developed, cut that error rate by 90%. And so, in generalities, I think you can expect a 30 to 60% improvement in through time and about a 90% improvement in quality, first-time quality.
Very good.
I've seen a lot of anecdotal evidence that goes more toward client engagement. So if you're a vendor and you're doing much earlier in the life cycle product design review and simulation with the client using some sort of virtual or augmented reality, that the return on investment is huge just in terms of that engagement with the client, making decisions or making changes much earlier in the life cycle are always a big savings. So I don't have specific numbers, but I hear that example over and over.
Yeah, we've actually, in those types of activities, we've taken 18-month design cycles, shortened them to 10 months. We've gotten through customer reviews, PDRs, CDRs with 0 action items because everything was, it was either designed correctly from being able to view everything in the virtual world and get a better idea of how everything's put together. Or in those reviews, the customer was able to enter into the virtual world and get a better idea of the design. And then also we've had factories that we have used virtual reality to bring in all the support functions to review, and we'll build the factories, put all of the equipment in place, and we'll have 0 change items. So a ton of cost avoidance there. And then the other thing we're trying to offset right now, it's kind of twofold. It's really just factory shutdown time. One on personnel. We are trying to keep up with demands from the customer, and so we need all of our factory experts, assembly experts in the factory, but they're also the ones who need to train our new assemblers. So we're trying to use virtual reality to offset the cost of having those experts off the line. And then also, we are constantly touring customers, different government officials through our factories. So we're also using virtual reality, augmented reality to create virtual tours to avoid shutting down factories for those types of tours as well. So not any real numbers there as far as cost-wise, but a lot of cost avoidance and a lot of just keeping our production going using virtual tools.
Have any of you run into any cybersecurity issues with your implementations of any of these technologies? And if so, what mitigation techniques can you offer the audience to help in that area?
I can tell you it just is a complication. So we have a lot of systems that are standalone, and they usually stand up and are working in a few hours or a day. As soon as you involve the IT department and you start going to an enterprise-wide system, it's just moving that data around it just becomes more complicated, and you need to account for the time that's going to take. And the biggest thing I would say, if you're gonna put in an enterprise-wide system, don't wait till installation day to start talking to your IT department. Start that way far ahead of that process.
In our systems, we have a lot of security at Lockheed Martin, and we found it very difficult to communicate the augmented reality information across our network. It took us many months, many meetings with security. Eventually, We wound up having to get like summits of all the security people, the web people, management in some cases, to try it, see where it stops, see what firewalls are in place that we can use, we can open. And in some cases, just putting the devices on the network is really not allowed because they're not fully qualified. There's security reviews that need to go through, and so that's still ongoing. I don't think anybody's really come up with a good set of head wearables that are secure yet.
Yeah, as much as this is a culture change for the design and manufacturing world, also it's a culture change for our security folks and IT. Getting those organizations, those support organizations, to adopt the need for these types of tools and just kind of continue to move forward. I totally agree. Get them involved way early on, and then find those boundaries, and that's how you kind of scope your work from there. We have a development project that we just got through proof of concept, and now we're trying to transition it to use actual Raytheon data, and this is something that we've had those support organizations involved the entire time, but we are drawing very clear boundaries, and it's actually kind of the basis of our architecture of our software development on that.
Okay, and last question that I have, and then we're going to turn to the audience for questions, and I'll check this technology up here, this augmented reality pad I have, to see what questions you're typing into Slido. Hopefully everybody's got that Slido thing going. All right. So what about safety? So, you see these videos of people walking into walls looking at their emails. I would imagine that wearing some of these headsets is a concern. Have you, had experience with that, and what have you done to address that issue?
Well, we are working on a head wearable device, but the main thing that we've done is get rid of head wearable devices. So augmented reality is by no means limited to something that you need to put on your face or be tethered in any way. Because obviously the best way to see augmented reality is to just walk up and look at it, and you don't need anything. So that's the way we did it, and it's so there is no blocking your views. Presently we're developing a HoloLens application, which our company would not allow that to go into production unless it was just at a workbench. Because people walking around wearing a HoloLens, walking on airplane wings or walking on structure of a passenger floor of a commercial plane, that's just an accident waiting to happen. So now I do believe that those things are going to, head wearables will be, they're improving all the time. Intel just came out with one that's, it's not augmented reality, it's assisted reality, but still very useful and not going to block your peripheral vision. So RealWear has the same kind of thing where it doesn't block your peripheral vision. So there's devices out there that are like that, but certainly the more full augmented reality things like HoloLens have limitations that would be worrisome to me.
Yeah, it does seem like the smart glasses have had an easier time transitioning to production floors. You don't have the limited sight that you would with some of the more mixed reality type glasses, but that's a start.
It's certainly an information overload concern. You wouldn't want to walk through a factory looking at a manual or a book. Same thing, you don't want to be distracted by information coming through any kind of a worn display. On the other hand, there's a lot of life safety issues that are easily addressed in terms of wayfinding, warning you that you're going into a safety concern area or a restricted area. So there can be passive things that only come on when necessary and can really help with safety in that regard.
Okay. All right, so here's a question from the audience. Does haptic feedback play a role in your mixed reality systems, and if so, how?
Yes.
the example I gave earlier of flight simulation, the realness of that really comes down to the haptics and the controls and the instrumentation physically that you're looking at as you interact with the virtual environment. So any type of machine operation, I think haptics becomes very important.
I would say for augmented reality, you wouldn't really have a haptic. That would be more of a virtual reality thing. Because if you are saying to torque this fastener to a certain torque value, you got the torque wrench in your hand. You feel the torque wrench. It feels just like a torque wrench. So you're not feeling a simulation of the thing. You're feeling the actual thing.
Yeah, and in the virtual world, we've found that we're still waiting for haptic technology to improve to a point where it is realistic, and it actually, if it's not realistic and you're in the virtual world and it says torque to this certain torque, and you're not actually feeling that, you can actually train your assemblers to have the wrong motion or the wrong ergonomics, and it can actually be detrimental in the complete virtual world. So yeah, I would agree. An augmented reality experience would be ideal right now because you can actually have the whatever torque wrench or whatever in your hand, and then in the virtual world, at least what we've found, we've scaled it. So we have our virtual reality trainer is supplemental to actual hands-on training.
So someone from the audience asked about motion sickness. Some people, not all people, some people experience motion sickness. Any developments to make this technology usable for everyone, even those that might have a problem with that?
Go ahead.
It's been decreased with the wider field of view, although with the augmented reality optical see-through, right now you basically only have about a 50-degree field of view. And the faster update rate of the screen has also been helping to make it more natural so your vision doesn't lag behind your head movement.
Also, just by not having a head wearable device, we have hundreds of systems that hundreds of people have been using for 9 years, and we never had one single case of motion sickness.
Very good. And what about culture change? Do you find that there's a significant change in the culture required with your operators to adopt this technology?
They love it. They love to use it.
They love it.
Sure, they all gather around when we have it out on the floor, and they all want to try it. They can't wait to participate. So I think it's a welcome change.
I've seen that as well. We have had a few cases where the workers on the floor maybe have the attitude of, why are you treating me like a baby, spoon feeding me this? I know how to do this job. But then once they have it, it's like, how did we ever do without this? So it's the culture change is easy to make happen once you just give it a try.
Yeah, I think the biggest barrier we run into is not necessarily from the user, because once you're in these types of environments, and get your hands on stuff, you actually understand the value real quickly. It's actually the people who are paying for the change in training, the change in design, trying to understand it's not just video games, it's actually value added. So it's most of the time just a matter of getting those people into the experience as well, just to understand the value.
Any specific examples in applying this technology in composite manufacturing?
Laser projectors is a type of augmented reality, and there are several companies that make excellent quality laser projectors, and they're used. I've been in apply layup rooms in aircraft plants all around the world, and I see those everywhere. So I would say that it's very common in composites. As far as assembly goes, our augmented reality system would be more useful for not for ply layup, but for assembling the structures.
Any questions from the floor for you non-Slido users? Yeah. So that's a great question. The issue regarding standards so that these various systems that are out there can communicate and collaborate with each other. Have you run into these issues?
Yeah, there is none.
Mostly they've been so unique that there haven't been communication between different head wearables to different devices. Although we've been using like one vendor for a lot of our AR, like Scope AR, and they work on HoloLens, iPad, Windows. So they've been able to take the data. Basically, if you're running Unity for your models, you should be pretty good with most everybody.
Yeah, I was going to say, choosing a platform like Unity, that's really the one. But you can build your executables for most of the commercial grade devices, especially in the virtual reality world. So standards as far as hardware, they're not really out there, but the software companies are trying to address kind of all the technology out there and use more standard software platforms.
So how does the digital twin tie into mixed reality?
I would say augmented reality really ties into the digital twin. So it's very easy to collect massive amounts of measurement data and make that. A lot of data is collected today, but then it's not available to any downstream processes. So because it was written on a piece of masking tape next to a hole or something like that, that masking tape gets peeled off and that data is gone forever. With an augmented reality system, those measurements can now be easily automated. You can make them in 5 or 6% of the time, and everything is documented to that particular location or that particular hole, that particular fastener. What is its flushness? What is its perpendicularity? So fast that it's almost it seems like a waste to not do it. And then again, all of that data is available to any downstream processes. So if you needed to make adjustments for shim values or the amount of liquid shim you're expecting at the next level, it's simple and easy to grab that information.
So look in your crystal balls and tell us, what do you think this technology looks like in the future? Where do you see it going?
Ubiquitous. Everybody's going to have it. You can't compete without it. It's going to be everywhere in your daily life. Your cell phone will be gone. You'll be using items on your glasses. Every part of your manufacturing process and business will involve augmented reality.
Yeah, I think actually one of the questions here, are you looking at integrating simulation into the environment? That's something actually that we are trying to push is not just creating this content and delivering it, but also having kind of real-time simulation, especially on the design side, bringing in the engineering analysis data so that we can overlay, thermal maps, stress and strain maps, that kind of stuff, and then, or even make a change to the product in the virtual world and then actually see it perform and see how the performance changes. That kind of stuff, that's all bigger data, more processing. As technology, just computer technology improves, it will flow directly into the graphics technology that drives all of this kind of stuff.
So are there any initiatives from AFRL to advance the adoption or the technology capability that you know of?
We've had several projects that I spoke of earlier, but we also plan on starting an effort. There's a team ongoing for virtual augmented mixed reality for aircraft maintenance called VAMRAM. We've put together kind of an example of how we think that could look with an F-15 notional model and walking an airman through doing a maintenance procedure. He then can, reach back to the SPO for subject matter expertise if he needs to. He can also pull up a 7 level for review of his work. So we have plans to proceed down that route. Also, there's a lot of looking at it for maintenance training environments. We can't always have a $200 million aircraft available for training, so training assets are limited. So we're looking at more virtual applications for maintenance training and that sort of thing.
Okay. So are there any questions that haven't been asked yet? Something that you feel just you really want to share with the audience about this technology that no one's asked yet?
It's probably easier to implement than you think if you're thinking that it's really hard. So for example, one of the things that we wanted to do, and we started working on this back in 2005, is CAD model data normally is going to come in CATIA and NX. So our system works in CATIA and NX. You don't need to convert your model into a thing that it isn't already. Wire harness data comes in various forms, including AutoCAD and others. So when we added wire capability, we added the ability to use data in the form that people have, which is very commonly a spreadsheet and 2D drawing. When we started doing paint systems, we wanted to do paint systems in paint programs that aircraft manufacturers used. And when we started doing metrology, we wanted to use Geomagic and Polyworks and Verisurf and metrology packages that people used. So because of that, it's actually pretty easy to implement an augmented reality system if you just start with systems that are focused on aircraft manufacturing, because that's the data that people already have.
Yeah, I would definitely share the same caution. If you're looking at a workflow that requires a lot of conversion of your data from one package to another, don't do that. You have those digital assets. There are solutions available that should directly make the best possible use of the asset in its native form.
Yeah, and I think along those lines, think about the support model. If you're having to translate all of your data into another format to deliver to whoever's going to be using it, then you become a support organization in and of yourself. So the more turnkey you can make the solution so that when data is updated, it flows directly into your virtual reality systems, augmented reality systems, the less manpower support you need just for those systems.
Okay, yes, we have a question over here.
How are you handling degradation of user performance from the fatigue of carrying around the weight of protective gear and attachments on the head and neck?
Everyone hear that?
Yeah, we haven't encountered that yet. The HoloLens is basically the one they've been using. It's a little heavy, but we've just been doing pilots, and we haven't had them wear it all day long. But I think you have to have one per person checked out to them all day long, and they're going to be getting lighter. We're working on ones in our own internal IRAD that are much lighter. But if you haven't tried a HoloLens, just another point, you should. If you haven't seen what a parallel virtual environment is like with things in your environment and the 3D aspects of it, you really should spend about 20 minutes or 10 minutes with one so you get used to it and see what's coming.
I'd also say that this is why many applications are done on a tablet, is because the headwear may not be comfortable or robust for a manufacturing environment, although that's constantly improving. The other thing I'd say is some of the things that will track task performance should easily give an indication of air rate or fatigue. through tracking that performance in the process. So there's some benefit to actually recognize that there is fatigue happening.
And I would say that with our system, the user you're adding a total of 0 grams to him. So, so obviously that doesn't add to fatigue. And in fact, the very opposite happens because of and I won't get into all the neuroscience here, but you're being able to transition information into the visual cortex. You don't have to process that in your prefrontal cortex. And the amount of energy that you don't burn by having to do symbology translation in your prefrontal cortex, what you will find is at the end of the very first day of using that, if the guys on the line will notice that they are significantly less tired than when they have been reading documentation and doing the symbolic transitions there.
Okay, one last question if anyone has a burning question. If not, can we thank our panelists for the very interesting discussion? Thank you very much.